Hello, ndikulandireni kuphunziro lathu lero pamene tikupitiriza ndi variations. Lero tili mu lesson 5 ndipo tiona partial variation. Ndipo muli ndine Sisera Jona. Pano tione kuti kodi tikati partial variation timanena kuti chani. This is the type of variation which consists of two or more parts added together. Ndipo tigwire mawu ti two, let's review this one. Two or more parts added together. Okay, two or more parts added together. Variations made on mbuyomu timangoona variation side yako left hand side and right hand side, and timaona timaona kuti ku right hand side kuli part imodzi, ku left hand side kuli part imodzi. For example, when we say x, when we say x to vary directly maybe to z, and there's a constant there. Okay, there is only one part here, and there's also only one part here. But for this, they're saying there can be more than one part here. You can have two parts or more parts and add them together. You can have something like x to be equal to a plus b z. Yeah, so this is what we are calling partial variation. So the relationship in these parts varies from question to question. It's master center. Now, since there are two or more parts added together, there are at least two constants. Yes. So the minimum constants you can have in a partial variation are two. You have two constants, you have three constants. But at your level, two constants are enough. Okay. These constants, we use them to solve this type of questions. Zimene kuona direct, inverse, joint variation, timakhala ndi one constant. But for a partial variation, we have improved. We are now having two constants. Now, by the virtue of having two constants, it's obvious that we will have two unknowns, and those two unknowns will need to be solved. And how do you solve those two unknowns? Is through using now simultaneous. Now, let's try this one. It's through using simultaneous linear equations. So we have covered simultaneous equations. Please go check on the videos on simultaneous equations that we have covered per page pomwe pano and understand them, and we're going to use them kwambiri in this lesson. Now, partial variation usually applies in situations where the value of one major quantity is the sum of two or more quantities varying in different ways. Okay, you can have, okay, let's take an example a minute. This example here. Okay, in this example they are saying cost of running a boarding school depends on, so the first thing you have cost. Okay, of a boarding school you have cost, and this cost, it's a major thing which is depending on a lot of things for this thing, for school to be run. Okay, so for example, running a boarding school depends on two separate factors, and these are overheads. Okay, overheads such as electricity. And when the boarding school mukuyenera mudzilipira mabilu amagetsi, mabilu amadzi, ngati mugwisa ntchito matelefoni mukhalenso mabilu amatelefoni, komanso even masalary amaziphunzitsi plus anthu ena othandizira ntchito. Komanso mbali ina, on the other hand, the cost of food used in the feeding students in the school. Now I want you to understand this. In most cases, overheads amakhala constant. Okay, monga bill ya wages, masalary. Kamuli maziphunzitsi 10, kaya okonza banja 10, salary yawo ikhala yomweyo. So that bill will not change. Okay, that is considered that, and those ones are paid without considering the fact that there are students in the school or not. Okay, kaya muli ba holiday, kaya simuli ba holiday, aziphunzitsi amalandirabe masalary. Ngati panali anthu okonza kaya makuki ophika ngati ndi boarding school, anthu amene aja amakhala kulandirabe masalary. Ndiye kaya mwabwera ku school, kaya simunabwera ku school, anthu amaja amakhala kulandirabe masalary. Those things are constant. Zimakhala kuti ndi mmene zililimo basi. Okay, let's continue and see. Now, the cost of food is the only quantity which is proportional to the number of students being fed to the school. So, timanena bajabu kuti for you to have a cost, the cost of running a school, you need to have one constant expenditures. The constant expenditures is my salary, let's say my salary represented by S. Okay, plus, okay, labor my cost 10 amena masinta. Okay, got annually, let's say food changes. Okay, got any body entire school anamaja. Okay, that cost is there during school time. Command time ene anatsekera, that cost ya chakudya chawana sima kalap. So school will not spend money on buying food when students are on holiday. So that's what we mean by the cost of food being the quantity which is proportional to the number of students being fed at the school. Therefore, we can say that the total cost is partly constant, varies. Okay, let's say maybe we put a constant there. It's partly constant, okay, constant, and partly varies in relation to the number of students. Okay, so I think we'll understand more when we look at an example. Okay, so the general equation, you can have y is equal to a plus constant k. Okay, so this one could be the value like the cost of running a school. This one could be the number of students. Okay, this is just a constant. And now we also have a constant. Salaries, salaries cooking, salaries and yeah. So this is a general equation, and from this general equation we are saying a and k, these are constants. Remember, I have already said you have these two. For you to solve those two, you need to know simultaneous equations. When you have two unknowns in any equation, you need to have simultaneous equation to solve. So the knowledge in simultaneous equations in this lesson is very important. Let's have an example. Okay, they're saying A is partly constant and partly varies with B. Okay, the first thing we need to understand from this statement to say A, okay, you have A, okay, will be equal to, let's say our constants should be A, constant, let's say A is constant, plus, and partly varies with B. Partly varies with B, because we have put an equal sign there, varies with B, we need to include a constant. In this case, let's say our constant is B, small b, okay? Yeah. So A is partly constant and partly varies with B. Okay, now the question is, from here, saying that when B is equal to 2 and A is equal to 10, and when B is equal to 4 and A is equal to 16, find the relationship between A and B. Okay, the first thing for us is to find the relationship between A and B. So this formula is the one that we have developed. It's obvious, it's a partial constant formula. Okay, and it's coming from that first statement. From this first statement, A is partly constant. It's partly A constant, which means it's just a number which does not change, and partly varies with B. Okay, so it has two parts. It has this first part and that second part. Okay, now on the second part of the question, they are saying when B is equal to and A is equal to 10. Okay, that is an equation. Okay, and when B is equal to 4 and A is equal to 16, that is another equation. So let's see how we can deal with that. So we can say equation 1, they are saying when B is equal to and when A is equal to 10, which means our A is this one, 10 will be equal to A plus B is equal to 2, in this case it will be 2B. Okay, this is let's have that so that we can have enough space. Yeah, that's equation 1. For equation 2, let's say equation 2. For equation 2, they say B is equal to 4 and A is equal to 16. So where there is A, we put 16, and this is our A. B is equal to, B is equal to 4, which means B. So we have two equations. Now, the first equation part, they are saying find the relationship between A and B. Find the relationship between A and B. This the relationship which is there between A and B. For us to find that relationship, we need to find the values of that one and that one. If we know the values of these two constants, that will give us the relationship which is there between A and B. So let's form here now. So now we need to solve these two equations to find the value of A and the value of B. Okay, so for us to achieve this, we need to use simultaneous equations. In this case, we're going to use, I think, elimination method. We're going to first of all eliminate A because they have the same coefficients here. So we can just subtract these equations. Okay, we can say subtract equation 2 from equation 1. Okay, so if we do that, we can say here, so 10 minus 16, that's negative 16, negative 6, sorry, negative 6, which will be equal to A minus A, that's 0, negative 2 minus 4, that's negative 2B. Yeah, from here we come here, which means make B subject of the formula. It will be B will be equal to negative 6 divided by negative 2, which will be equal to 3. Okay, then after finding here, then we can find A by substituting. Let's take the first equation and say substitute B into equation 1 to equation 1. So by doing so, we'll have 10 is equal to A plus 2, where there's B, we're putting 3, like that. So in this case, you have 10 is equal to A plus 2 times 3, that's 6. Okay, which means A will be equal to 10 minus 6, which will be equal to 4. Okay, so the value of A we found, the value of B we find. Okay, so that means now we have the value of A as 4 and the value of B as 3. Therefore, Therefore, the relationship between A and B for A, that is, let's say therefore, the relationship between A and B will be equal to, okay, so that relationship will be, that's our A, okay, where there is small a, we are going to put 4 plus, where there is small b, sorry, plus, whereas there is small b, we are going to put 3, okay, 3, in this case, 3b, okay, so how the relationship is A is equal to, sorry, so that relationship we have found to be A to be equal to 4 plus 3b, okay, so basically that's that. Then the part B of the equation, B, you know this part B, find, you can say finding A when B is equal to 5. Okay, so when B is equal to 5, we can find A. So since A is equal to 4 plus 3b, so when this B is equal to 5, what will be the value of A? That's what they want us to find. So if we do that, you'll find out that A will be equal to 4 plus 3 divided 5 should be equal to, that's 15, that's 4. So 4 plus 15, that will be 19. As simple as that. Okay, so that's how we approach these problems. Let's look at another one. In this one, they're saying A varies partly as C. A varies partly as C. Okay, varies partly as C. A varies. It varies. It's not a constant. It varies partly as C. So you have A will be equal to varies partly as C. Let's say A varies partly as C, and in this case plus partly as square root of C. So the constant will be that square root of C, something like that. Okay, in this case we can say where A and B are proportional constants. Okay, we can say that are constants. Okay, A and B are constants. Okay, this is how they happen. It has two parts. Partial variation is just like that. So what they are saying now, when C, this C is equal to 4, and when A is equal to 22, and when C is equal to, so let's find the relationship which is there. And the relationship which is there, we can say we need to have two equations. In this case, we have equation 1, that is when C is equal to 4, and when A is equal to 22. So we can say equation 1 can have 22 will be equal to AC. This C, the saying is 4A plus B. Okay, something like that. That's equation 1. Okay, and equation 2. Equation 2 could be C is 9 and A is 42, and that's our A. So it will be 42 is equal to the C here, it will be 9C plus here will be square root of, let's see, there is 9. Okay, so let's simplify this one. If we simplify that one, it will be is equal to 4a plus square root of 4, that's 2b. Over here it will be 9c plus square root of 9, that's 3b. Okay, so we have two equations. We have this is our equation. We have 22 is equal to 49 plus, not 49 but 4a plus 2b, that's equation 1, and we have 42 which is equal to 9c plus 3b which is equal to that's equation 2. Okay, so let's solve this one using we are doing elimination method. Okay, so let's continue. These were our equations. We had 22 to be equal to 4a plus 2b, and this was equation 1, and we had the 42 to be equal to 9a. Okay, 9a plus, in this case, 3b, this to be equation 2. Okay, elimination methods of solving. We can multiply the upper. We can the simple one to eliminate is b. The simple one to eliminate is b. So we are going to multiply the equation 1 by, I think, 3 to make it 6, and we're going to multiply equation 2 by 2 to make this part 6 as well, so that we can eliminate b. So we can say eliminate b. Of course, we are using simultaneous equation. So to achieve that, we are going to multiply the first one with 3. So 3 multiplied by 22, that's 66. 66 is equal to 3 and 12 and 4, that's 12a plus, and that one, that's 6b. Okay, and the bottom one, 42 times 2, that's 84, which is equal to 2 times 9, that's 18a plus 2 times that one, that's 6b. Okay, so we are going to subtract 66 minus, so let's say 66 minus 84, what do we have? That's minus 18, which is equal to 12 minus 18a, 12a minus 18a, that will give us, so 12 minus 18, so that's minus 6a. 6b minus 6b, that's 0. So we divide both sides by a, make some geometry formula of a. So minus 18 divided by minus 6. What we have? We have a as 3. Okay, that's our a. So for us to find b, we have to substitute. We can substitute for 3 for a in, we can say, in equation 1. That's a bit simpler in equation 1. Okay, so let's have more space here. We found out that if we substitute that into equation 1, we will have 22. No. It's not be there. Let's have, yeah, we can substitute it anywhere. Yeah, okay. So we can have 22 is equal to 4, this A we put 3 plus 2b. Okay, so that will mean 22 will be equal to 4 times 3, that's 12, plus 2b. So 2b will be equal to 22 minus 12, and 22 minus 12, that gives you 10. So you have 2b is equal to 10, which means b will be equal to 2 divided by both sides. There will be b, and there will be 5. Okay, so which means we have found the value of b. Okay, now the equation now will be equal to a will be equal to, okay, remember it was AC plus sorry, I think it was plus square root of C there, something like that. So the relationship between these two, it will be equal to A will be equal to, we know A, which is 3C, plus we know B, which is 5 root C. Okay, it's as simple as that, which means the relationship between, this is the relationship between A and C. So if they want to find you the value of A, they need to give you C. If you put C, the value of C, you get the value of A. Or if they want you to find the value of C, you put A, then you find the value of C. It's as simple as that. Let's continue. Now let's look at how we can present this information, presenting partial variation graphically. Already ngati munaona zinthu zathu ija ya formula yathu ija inayonena kuti it was more or less like this one, and this equation is not new. This is an equation of a straight line. It's an equation of a straight line, which means partial variation graphs have to be straight line, because if you remember, manena kuti you can have let's say C to be equal to constant plus B and maybe B. Okay, so this format is more or less like that one. Okay, which means the equation of a partial variation is a straight line if you put it graphically. All right, let's continue. Let's have an example on it and say on how we can do on what we can do with it. Okay, now so let's try by looking at this one, by looking at this example. Okay, in this example they're saying y is partly constant and partly varies as x. Okay, partly constant and partly varies as x. Okay, partly constant. Okay, so this y is equal to partly constant. So I put a constant, we let our constant to be a, and plus partly varies. Okay, so we need to have a constant partly varies with as x. Okay, so this is our the general partial variation equation that we can derive from that statement. Now in this case, let's develop our two equations which will help us to find a, constant A and constant K. By finding these constants, we'll be able to develop a relationship between y and x, and with that we can draw our graph. Okay, so we are saying when x, that's let's say equation 1, that is when x is equal to 10, this x is equal to 10 and y is equal to 2. So we can say 2 to be equal to a plus, when there's x we put 10, so it will be 10k. Okay, so that's our first equation. Our second equation, equation 2 will be equal to, when x is equal to 4, y is equal to 14, so it will be 14 is equal to a plus, where there is x, we put 4k. Okay, so the same stuff. So using elimination method, let's maybe cut here. Using elimination method, let's eliminate. In this case, we are going to eliminate a, because the simplest one to eliminate. We don't have to do anything to it, okay? Because the coefficients are the same, 1. So eliminate a. So if we eliminate a, we can say that we have 2 is equal to a plus 10k. This is equation 1. And we have 14 is equal to a plus 4k. This is equation 2. Okay, so if we subtract here, it will be negative 12. That's 0, so we'll not put it to be equal to 10 minus 4. That's 6k, which means k will be equal to, k here, k will be equal to, make k subject of the formula will be minus 12 divided by 6, which is equal to negative 12 divided by 6, that's negative 2. Okay, that's negative 2. That's okay. And our a, we are just going to substitute. So substitute negative 2 for k in 1, in equation 1. Okay, so if we do that, we will have 2 is equal to a plus, okay, a plus, in this case 10, where there's k we put negative 2. Okay, so let's take this one to here for space. So we have 2 is equal to a plus plus 10 times negative 2, that's negative 20. So this will be equal to a minus 20. Okay, so alright, yeah. Let's put it this way. So this will be equal to 2 is equal to a minus 20. So make subject of the formula a equal to 22. If a goes to the other side, 20 plus 2 will be positive, so 2 plus 20, that's 22. Okay, so reaching this far, now the relationship, our equation, this equation will now be y will be equal to a. We know a is what? A is 22. K we know it's negative 2 minus, we put where there's 2, where there's k 2, so 2x, something like that. So the relationship which is there is y is equal to 22 minus 2x. So the relationship between y and x is this one. Okay, so let's take this one onto a graph paper and see what does it give us. Okay, so let's bring our equation here. Now it's y is equal to 22 minus 2x. Okay, so we can we can do this by saying, when, since we know it's a straight line, we can say when x, let's say when x is equal to 0, which means when that is equal to 0, which means y will be equal to 22. Okay, when y is equal to x, which means, when y is equal to 0, we can say when y is equal to 0, the x will be 0 is equal to 22 minus 2x. So we are capital, it will be 2x is equal to 22, which means x will be equal to divide both sides by 2 is equal to 11, which means we can put up our Euclidean plane. Okay. This is x-axis, that is y-axis. This is 0. So on the x-axis, let's say 1, okay, this is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So let's say our 11 is there. Okay. And there 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Somewhere there. Okay. So this is 11. So this is a sketch. So this one. So that's a straight line. Okay. Choose. This is equal to y. It's got 22.2x. Okay. So from this graph, when you know at any point you'll be able to understand let's say when x is equal to, let's say when x is equal to 1, 2, 3, 4, 5. Okay, when let's say when x is equal to 5, you come there, you go up to where it's cutting there. For you to find the y value, you can come there without even solving, by just using the graph. So for today, I think we have covered a lot. Let's stop there. Meet you in the next lesson, and I think the next lesson is a new topic. Here concludes what we had in variations. See you next lesson. Thank you.